Today we are going to explore the concept of immune complexes. We will cover three key areas. First, their definition. Second, how they develop and are cleared. And finally, we will look at important clinical examples where these complexes cause disease. Let's get started. So what exactly is an immune complex? As you can see here, it is quite simply structure formed when an antibody binds to an antigen. The antigen could be something foreign like a protein from a bacteria, or it could be self-antigen from your own body. The antibody, usually IgG or IgM, look onto this antigen to neutralize it. This binding creates the complex you see on the screen. Not all immune complexes are the same size. Their physical property depend heavily on the ratio of antigen to antibody. If there is too much antibody or too much antigen, the complexes tend to remain small and soluble. However, in the equivalent zone, where amounts are roughly equal, they form large lattice-like structures. These large complexes are often insoluble and are the most likely to cause problems. In a healthy individual, the formation of these complexes is a normal immune response. Typically, they are tagged by the immune system and quickly engulfed by phagocytes, the cells that eat debris. They are then transported to the liver and the spleen, where they are safely destroyed and removed from circulation. This is how the system should work. The pathology begins where these complexes are formed in excess and cannot be cleared fast enough. Instead of being removed, they travel through the blood and get stuck or deposit in specific tissues. As shown here, the most common site for this deposition are the kidney, the blood vessel walls, the skin, and the joint. These are areas where blood is filtered or flows under high pressure. Once deposited, these complexes trigger a destructive chain reaction known as a type 3 hypersensitivity reaction. The deposited complex activates the complement system, which acts like a distress beacon. This recruits inflammatory cells, specifically neutrophils, to the site. These cells release enzymes that damage the surrounding tissue, leading to inflammation and vasculitis. This is the core mechanism of the disease. Now, let's look at clinical examples. The most famous is systemic lupus erythematosus, or SLE. In lupus, the body produces antibody against its own DNA. These DNA antibody complexes circulate and deposit widely. This leads to inflammation in the kidney, the characteristic butterfly rash on the skin, and the pain in the joint. And secondary example is PSGN. This occurs after an infection like strep throat. The body fights the bacteria but the resulting immune complexes get trapped specifically in the kidney. This causes acute inflammation, disrupting the kidney's ability to filter blood, often leading to blood in the urine. To summarize, immune complexes are normal antigen antibody structures. However, when they persist and deposit in tissue like the kidney or joint, they trigger significant inflammation by type 3 hypersensitivity. Understanding this mechanism is the key to diagnosing and treating disease like SLE or PSGM. Thank you very much for your attention.